Hello everyone, welcome to NS Academy. So first of all, before going into the video, I would like to say that whoever gave the scholarship test and they have been ranked and the coupons are already generated for you. So the scholarship is already issued. So you can basically buy the courses now. The courses buying will not be available after 15 January for this ISI-CMI course. So that is the validity of the course. That is the validity of the registration of the course actually. So do hurry up, and also if you have not given the test yet, it is high time you should give that. You should follow the instructions given in the description and also in the Telegram channel and WhatsApp group as well. So let us get back to the topic of today's video, linear Diophantine equations. First of all, what is Diophantine equations? Now Diophantine equations are basically number theoretical equations. These are only made using positive integers, negative integers, or integers as a whole. So these are same as that we have heard of equations, right? We do equations all day, but linear Diophantine equations would look something like this. Let's say you have x square plus y square equals to z square, and where x, y, z are all integers, and you might be asked to solve this equation. So in general, what we have learned is when we have an equation and we need the same amount of equations as much as the unknown variables, right? Only then can we solve them perfectly. That is not true in case of linear Diophantine equation. It's a part of number theory, which is one of the most famous subsections you could say, because here in a single equation you may find 2, 3, 4 or even hundreds of variables, and those equations are still perfectly solvable using tools. So these are the problems which will require creativity, intelligence, and of course a lot of knowledge as well. For example, the one I have wrote here, x square plus y square equals to z square, right? So this is the Pythagoras theorem, you all know that. But do you know that there are infinitely many integer solutions to this? Of course, one could always argue that 3k, 4k, 5k is a infinite solution to this equation, where this is x, this is y, this is z, where k is any integer. Which means if you put in any value of k, each of those values of k will produce a triplet, and they will be the solutions to this equation. So you can say there are infinitely many integer solutions. There are also a simple generalization. If you put x as a square minus b square, y as 2ab, and I think z as a square plus b square, I think that also holds. I think this also gives you a square minus b square whole square plus 4a square b square is simply equals to a square plus b square whole square, right? So this is again a general solution to this equation. So now let's come back to the topic of linear Diophantine equations. Now these equations look like this: a into x plus b into y is equals to c, where a, b, c are all integers, and of course z, x and y are something you have to solve for. Obviously they will be integers too. Now the first condition for an equation of this kind to be solvable, where all entries are integers, the first condition is the GCD of a and b, which means the greatest common divisor or the highest common factor HCF of a and b, which can be written in this notation. This is the notation that is followed by mathematicians to write the GCD of two integers. This must divide. This notation is to note that something divides something, c. So as long as the GCD of a and b divides c, this equation has infinitely many solutions. And if it doesn't divide c, then this equation has no solutions. Now, how can we do this? So if the GCD is a comma b, let me say that GCD is a comma b. Let d be the GCD. What does GCD actually mean? Well, that would mean that d is the highest factor present in both a and b, right? We can simply write that a is equals to a prime into d. So there a obviously would be equals to d into d times some integer a prime, right? And similarly b would be equals to b prime d. And we can understand that a prime and b prime would be co-prime, because d was the highest common factor present in a and b. So a prime and b prime cannot have any common factors, right? Otherwise that would violate the point that d is the highest factor in a and b. Now put this value in here, you would see the left hand side simply becomes d times a prime x plus b prime y equals to c. Now you would see d is a positive integer, this is a positive integer, and c is a integer as well. So they may not be positive integers, but they are integers. Now product of two integers equals to c, which means this must divide c and this must divide c as well, right, in some order. So we can say this equation has only solutions when d divides c. which is to prove our initial claim that A comma B must divide C, right? This is D divides C. Done. Now, if D actually divides C, then C can also be written as D into C prime, right? And now D will cancel off from both sides and you simply get the equation A prime X plus B prime Y is equals to C prime. And now this equation can simply be said that, okay, A prime by C and B prime by C, both of this C prime will divide A prime and B prime both, which means this reduces to the fact here that you can simply write this equation as ax plus by equals to 1 in a more simpler form. And this has infinitely many solutions. So you can rather write ax minus by equals to 1. That would give me a better way to do this. So the answers are like this: x naught plus k into b, and y should be y naught plus k into a. Now what is this answer? The thing is, x naught and y naught are the initial solutions which satisfy ax naught minus by naught equals to 1. So in order to find infinitely many solutions to an equation of this kind, you first need to find one such solution which can be found using the Euclidean division algorithm. And once you find this, using this x naught and y naught, you can generate infinitely many solutions of xy using this, where k is your parameter. You can simply roll down k to any number of values. So k is basically an integer. It can be 2, it can be 200, it can be 2000, and all of this will produce solutions. You can put this into it to see that if it works or not. So these are linear Diophantine equations. These are asked commonly, but the most important point is this, that it has a solution only and only when the GCD of A and B divides C. So it's an important topic, it's an important concept in linear equations, so you must know it. That is why I made this video. So I guess thank you again for watching the video, and also if you are new to the channel, do subscribe. And if you haven't downloaded the app yet, please check the description for the links, and also apply for the scholarship test if you haven't yet. Thank you. If there are any comments, let me know in the comment section.